Okay, in lesson 5.3, we'll be looking at permutations and combinations. And here's a basic definition of a permutation. A permutation is an arrangement of objects where order is important. A combination, on the other hand, is an arrangement of objects where order is not important. A very basic example would be, say, the number 123. 123. If I switch some of the numbers to say make it 3, put the 3 first, and then the 2, and then the 1, that's a different number. So with numbers, order is important. Now, on the other hand, if I have a set consisting of the numbers 1, 2, 3, it doesn't matter what order I put the numbers in, it's still going to be the same set. So if I put the 3 first, and then the 2, and then the 1, it's still the same set. If I put the 1, the 3, and then the 2, it's still the same set. So the order there is not important. Okay, now as further examples, let's consider the letters A, B, C. Now if I take 3 of the letters, all 3 at a time, then I can arrange them in this format: ABC, ACB, BAC, BCA, CAB, CBA. There are 6 permutations because the order is important, just like with the numbers 123. So if I'm taking order to be important, there would be 6 permutations. However, if order is not important, then this is just one combination of the letters. ABC would be the same thing as ACB, the same thing as BAC, the same thing as BCA, CAB, CBA. So in this case, if I take 3 of the letters at a time, I would have 6 different permutations, but only one combination. Now if I take 2 of the 3 letters, so say I take the A and the B, I get A, B, B, A, and then the B and the C, I get B, C, and C, B, and then the A and the C, I get A, C, and C, A. So I take them 2 at a time, then I would have 6 permutations. Order is important. A, B would be different than B, A. B, C would be different than C, B. A, C would be different than C, A. However, I would have 3 combinations, because for combinations, order is not important, so AB would be the same thing as BA. BC would be the same thing as CB, and AC would be the same thing as CA. So 6 permutations if I take 2 of the 3 letters, and 3 combinations. Now in an earlier lesson, when we're dealing with binomials, we used this formula here. C of n comma r, or n over r, is n factorial over n minus r factorial, and this is the number of combinations of n distinct objects taken r at a time. And again, order is not important. This is the formula we use to find the coefficients of the binomial expansion. The next one is the formula for permutations. Very similar, except it doesn't have that r factorial in the bottom, so it's n factorial over n minus r factorial. This is the number of permutations of r objects chosen from n distinct objects without repetition. Order is important. Okay, so as an example, applying this formula, if I want to find the number of permutations of 3 things taken 3 at a time, okay, and we just went over that, I would write it then in this format: P of 3, comma 3. And then using the formula for permutations down here, n is 3 and r is 3. So this would be then 3 factorial over n minus r factorial, but that's 3 minus 3, so that's 0 factorial. You recall from the earlier lesson, 3 factorial is, or 0 factorial to start off with, is 1, and 3 factorial is a product of consecutive numbers from 1 to 3, so that's 1 times 2 times 3, 1 times 2 times 3, that's 6. So I get 6 over 1, which is 6. Okay, so the number of permutations of 3 things taken 3 at a time is 6, which is what we counted here. Okay, now if I want to look at combinations of 3 things taken 3 at a time using the other formula, I would have it 3 over 3. So n is 3, r is 3. So using the formula, this would be 3 factorial on top. N minus r, that would be 3 minus 3, that would be 0. So this would be 0 factorial down here times r factorial, but r is 3. So this is 3 factorial. Okay, well 3 factorial is 6, 3 factorial is 6, so the 6's cancel out, 0 factorial is 1, so this comes out to 1. So this tells me then the number of combinations of 3 things taken 3 at a time is 1, which is what we got over here. Okay. Now, computing this out for 3 things taken 2 at a time, again, so let's find the permutations. Permutations of 3 things taken 2 at a time. So again, using the formula for permutations, this would be 3 factorial over 3 minus 2. It's 1, so that'd be 1 factorial. So 3 factorial again is 6, and 1 factorial is just 1. So this will give me 6, which is what we counted over here in for the 2 taken from the 3. Okay, if I want to use the formula for combinations to compute the second part, well then I would set this up then as 3 things taken 2 at a time. So that would be 3 factorial divided by 3 minus 2, that would be 1 factorial, times r factorial, r is 2, so this would be 2 factorial. Okay, so 3 factorial is 6, 1 factorial is 1, 2 factorial is 2, so I have 6 basically divided by 2, which is 3, which is what we counted for the number of combinations of the 3 things taken 2 at a time. Now in the earlier lesson, I also showed how you can compute these permutations, or combinations rather, using the calculator. You can do the same thing with permutations, very similar. So let's look at the examples here. So find the value of each permutation. So you could use the formula that I just went over, or if you have a graphing calculator, in this case I'm using TI-83 Plus, enter the 6, okay, and then go to your math menu, click on math here, and then go over to the last item menu there, probability, and the second one, NPR, that's your formula for permutations, hit a 2, and then enter the second value there, which is a 2. So in this case the N is 6 and the R is 2, hit enter, and the number of permutations of 6 things taken 2 at a time is 30. For the second one, number of permutations of 8 things taken 3 at a time, enter the 8, and then go to the math menu, over to probability, again number 2, and then enter the 3, hit enter, we get 336. And then the other 2 are done similarly. You have the answers there in case you want to compute those on your own. Okay, but those are the answers for C, 1680, and for D, 210. Okay, let's go to the next one on combinations. So using the calculator again, find the value of each combination. So for A, it's combinations. Again, sometimes you use the 2 forms here. It has a C for combination. So C of 8, 6 means the number of combinations of 8 things taken 6 at a time. So again, we enter the 8. Then just like the permutation formula, go to math, go to probability, And number 3, NCR, that's combinations. Enter the 6, hit enter, and we get 28. Okay, we'll do one more of these. The second one, B, combination of 7 things taken 2 at a time. Enter the 7, over to math. Probability, number 3, enter the 2, hit enter. Okay, so the answer is 21. Number of combinations of 7 things taken 2 at a time is 21. Okay, the next one, we actually did an example like this, a couple of examples in the last lesson, but here's what we have. How many 3-letter codes can be formed using the letters A, B, C, D, E, and F and G? So there's 7 letters, and we want 3-letter codes. So basically there's 3 positions, and it says repeated letters are allowed. So using the multiplication principle of counting, which we also touched on in the last lesson, since you can repeat letters for the first choice, we have any one of the 7 we can select. For the second, any one of the 7, and for the third, any one of the 7. So according to the principle, we multiply this out. So we have 343 3-letter codes that are possible. Okay. Go to the next one. We have a student dance committee is to be formed consisting of 3 boys and 4 girls. If the membership is to be chosen from 8 boys and 7 girls, how many different committees are possible? Different committees are possible. Okay, so it says using the multiplication principle of counting and combinations we have. Okay, so again, we're using the multiplication principle of counting to start off with. So in other words, we want to know in how many ways can we select the boys, and for the second one, in how many ways can we select the girls. So we're selecting 3 boys out of a possible of 8. Okay, so that's where I get this first expression, 8 select 3, and we're selecting 4 girls out of a possible 7 girls, so it's 7 select 4. Okay, so 8 select 3 is the number of ways of selecting the boys, 7 select 4 is ways of selecting the girls. So according to the multiplication principle, we multiply those to get the total different ways of forming this committee. So 8 select 3, using your calculator in the same way in the previous examples, you'll get 56. And again, using your calculator to compute 7 select 4, we get 35. Multiply these out, and we get 1960, or 1,960 different committees. It's important here to note that we're dealing with committees, so in general, that's dealing with combinations because order is not important. The only way it would be important is if you're selecting, say, a president, a vice president, and a secretary. But this is just a member of committees, or members of a committee. So the order is not important. That's why we can treat it as a combination. And based on the way it's stated, we use the multiplication principle of counting. Okay, we're going to use some of these formulas also in the final lesson of this chapter, which will deal with probability. So stay tuned for those, and please post any suggestions or questions you might have. And again, if these are helping you, please subscribe to the channel, and we'll see you in the next video.